Welcome back, and this is session 2. So, in this, we'll start with the assignment which was given to you in the last session. And the questions were: what is hardware and software? What is coding? And what do you want computers to do after your instructions or codes? So, hope you have found your answers, but if not, let me try to answer them for you. So, what is hardware and software? Any part of the computer which we can see and touch is hardware. Example: monitor, mouse, keyboard, printer, hard drive, etc. Set of instructions that tell a computer exactly what to do is software. Example: Microsoft Word, Photoshop, VLC player, browser, which can be of numerous types, etc. The second question was, what is coding? So, coding is a process of creating instructions for computers using programming languages. Coding is used to program the websites, apps, create games, and other technologies we interact with on a daily basis. And the third question was, what do you want your computer to do after your instructions or codes? So for me, I would like my computer to order food for me, make me learn my subjects, make a video call, help me making a robot, run a game for me, etc. Hope this answers the three questions. So time to go forward. So here we have some basics which will actually help us throughout the learning of Scratch. So we'll begin with stepwise thinking and logical thinking. To draw out the conclusions, I'll give you some basic examples. Based on the answers, we'll figure out which one is stepwise and which one is logical thinking. So the first one is: Joshua wants to brush his teeth. Sequence the pictures so that he gets sparkling white teeth in the end. So here we have A, B, C, D, E, F. Now we need to sequence them in such a way that Joshua gets sparkling white teeth. Put on your thinking caps and keep thinking. So let's put these pictures into a sequence so that Joshua gets sparkling white teeth in the end. So here we have the first one. We apply the paste onto the brush. Joshua opens his mouth. He applies the brush, goggles, and rinses with water. And finally, we have the sparkling white teeth. So instead of the sequence A, B, C, D, E, F, we have A, D, C, E, A, D, C, F, E, B. Okay, now another sequence. Hope you like some stories. So this one goes down to the story of the thirsty crow. So if the crow has to drink water, how should we place the pictures? Again, put on your thinking caps and keep thinking. So let's sequentialize them. So the crow was really thirsty, it was hot, it found a pot which had little water, it applied an idea, and the idea was to put the pebbles into the pot. The water level rose up, the crow drank water, and it flew off. That was again stepwise. That means we are actually putting the things right after one another. And if we don't follow the steps, we will never reach the output, isn't it? Now let's go to the next example. So herein we have numbers. Hope you like numbers. 143690258 Now the question is, arrange these numbers in a sequence. So if you start arranging them, the sequence is going to be something like, no, 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 put on your thinking caps and keep thinking. So the sequence is going to be something like this. And if I ask you, what are these digits? Definitely you will come back with an answer that these are the decimal numbers. Okay, another mathematical sequence for you. So try to arrange these numbers 181, 9, 4, 25, 36, 49, 16, 64, and 1 in a sequence. It's up to you whether it can be an ascending order or a descending order. Put on your thinking caps and keep thinking. If at all I put them in ascending order, it will be 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. And what are these digits? Definitely these are the squares of the numbers from 1 to 10. Okay, in both these situations 1 and 2 related to the numbers, we had to follow a sequence of steps to get the desired output. In computers too, the same things happen. Let's go with another one. Now this time it's going to be a different one. So we have frames and some shapes. Let's fit the shapes into the frames. So we have the wireframes of a rectangle, square, a circle, a triangle, and a flower. So each one is going to fit only a particular shape. Now herein, we can actually do a hit and trial. We can try to fit the circle into the rectangle or the triangle into the square. But alas, we'll find out that only a rectangle frame will fit the rectangle shape and only a circular shape will fit the circular frame. That means we can randomly try to fit the shapes and a task will be accomplished without any particular sequence. That means there are problems which get solved in a sequence and there are problems which can be solved without even following a sequence. Let's go with another one. So hope you must have studied about circuits in which you have a bulb, you have a cell, and then you have some wires and you have a switch. You put the arrangement into action and then figure out in which of the following cases will the bulb glow. So put on your thinking cap and keep thinking. So if we have to come to a conclusion, so definitely it's going to be the bulbs which are having a complete circuit. So bulb which is connected to the circuit number 1 and the bulb which is connected to the circuit number 6 are the only ones which have a complete path and they are the ones to glow. In this task, we can randomly try to check the correct ways of making the bulb glow. No sequence is supposed to be followed, isn't it? Now, based on our understanding, let's try to figure out what exactly do we mean by algorithm. In computers, we have something called an algorithm, and it is a procedure or a step-by-step instruction for solving a problem. This makes us think in steps, and such thinking is called stepwise thinking. Hope it connects the examples which you have recently observed. Algorithms form the foundation of writing a program. Here, the program is instructions given to a computer for a particular task. For writing any programs, the following has to be known: input, tasks to be performed, and output expected. Let's have some more examples. Do you think such a tree exists on Earth, or is it graphics? Yes or no? Put on your thinking cap and keep thinking. So the answer to this question is yes, it does. And it even allows an SUV to pass through it. Strange, isn't it? These are the sequoia trees which are there in California, USA. Let's have another situation. You must have come across this in your science subject. There is something called burning of wax and melting of wax. Now, which among the two is a physical process? Burning of wax or melting of wax? Put on your thinking cap and keep thinking. So definitely melting of wax is a physical process because no new substances are formed. Let's rediscuss. We have logical thinking, which is a process in which one uses reasoning consistently to come to a conclusion. This also means that we think in a manner to make sense. Also, we had broken down big tasks into small tasks. We have something called decomposition, which also means to break down a complex problem into smaller parts. After all this discussion, let's summarize the main points. Algorithm is a procedure or step-by-step instruction for solving a problem. They form the foundation of writing a program. Programs are instructions given to a computer for a particular task. For writing a program, we need to know input, task, and output. When we logically think, we have a reason to come to a conclusion. And lastly, decomposition is breaking big problem into smaller parts. With this, we complete the basics we had to know for learning Scratch. Now, let's see how the Scratch interface is and how do we name the different parts. So here we have the Scratch interface. So the main part is actually the stage part where the sprite performs, and all the sprites actually come to us from something called sprite library. At times there is also a backstage or a backdrop which actually comes from a backdrops library. Now the stage can be minimized or maximized, and there are stage modes for that, which you can actually see on the right top corner of the screen. And to make the sprite or the program perform or stop functioning, we can actually use the start and stop with the green flag and the red button. For arranging all the blocks which actually make the logic in the program, we have the scripts area. So the programs which we make over here are basically the scripts. And this particular portion actually represents the sprite info. Now for pulling out the blocks which are actually available in the different colors on the left side of the screen, we have the block palette. And these all appear with the help of tabs which are three numbered: code, costumes, and sounds. And there are a few more added functions which actually come with add extension. So we'll learn all about these. And then we have a backpack which stores all these things. Apart from this, we have the menu tab. And then there is also a user tab on the right side of the screen. The file name appears here. So that was all about the Scratch interface. So here we come to an end of this session. So we have assignment over here. Try to do following. Open Scratch, whether online or offline, and explore it. See what all can be done. Get used to the screen environment and especially the names which I have shared recently with you. Make sprite trace the path on screen with different color trails. I do understand we haven't done any program and I'm expecting you to make a program which actually makes the sprite run on the screen and then produce some different colored outputs, but you can give a hand. And then try to make a square with side length as 100. Let's see whether you are able to do these three or no. With this, we come to an end of this session and meet you again in the next one. Till then, happy learning.